Hello and welcome to this question from the Year 2 A-Level book. This is Chapter 7, Mixed Exercise, Question 26 on Trigonometric Modelling. Okay, first of all, we have to expand using the addition formulae r sine theta minus alpha. Okay, and that is r times the sine of theta times the cos of alpha plus, or rather minus, r times the cos of theta and the sine of alpha. Okay, that's the addition formulae in use. Okay, now we equate coefficients. So we've got to set that, the thing we've just written down, to be the same as 1.4 1.4 sine theta minus 5.6 cos theta. Okay, equating coefficients, it means that the 1.4 must be the same as r cos alpha. Okay, so 1.4 is the same as r cos alpha. Okay, and also 5.6 is the same as r sine alpha. And because sine alpha over cos alpha is tan alpha, and the r's cancel, I can conclude that tan of alpha must therefore be 5.6 over 1.4, which is exactly 4. Okay, and from that I get alpha equals 75.964 degrees to 3 decimal places, which is what the question asked for. Okay, so that's the value of alpha. Now to find r, I use the fact that if I square and add these terms together, so the r sine alpha squared is r squared sine squared alpha plus r squared cos squared alpha, that would give me 1 times r squared, because sine squared plus cos squared is 1. So I know that if I square and add these two terms, I would get r squared. So r is therefore the square root of 1.4 squared plus 5.6 squared. Okay, and if we put that on the calculator to 3 decimal places, it will give us 5.772. And that's the value of r that we are required to give. Okay, now in part B, we have to use what we've just done by expressing this original function now in the form of, so we have 1.4 sine theta minus 5.6 cos theta, and we now know that we can write that as 5.772 times the sine of, and it's theta minus alpha, which is theta minus 75.964. Okay, so what we've done is we've written it in a form where it's easy to see its maximum and minimum values. You see, sine of an angle is restricted to between -1 and 1. So the maximum value of this whole thing here occurs when sine of the bracket equals 1. Okay, so I say that that's maximum when the sine of that is 1, or indeed when theta minus 75.964 is equal to 90 degrees, because the sine of 90 degrees is 1. Okay, which means that theta equals 90 plus that, which is 165.964. Okay, so what is the maximum value? Well, it occurs when theta is 165.964, and because that causes this part to be 1, the maximum value is actually equal to 5.772 times 1, which is 5.772. So the maximum value that they require is that, and it occurs when theta equals that. So I've answered all parts of question B because there were 2 things it needed. Now we're then going to convert this model that we've just made into this thing here. Now it's exactly the same as what we've got here, okay, except they put the minus 5.6 now in front and the 1.4 sign afterwards, but that doesn't matter. But they've also added a 12 to it by putting the 12 in front, and they've changed the theta to this thing here, 360t over 365. And t dt is the number of the length of daylight time at a location in northern Scotland, okay, where t is the number of days into the year. So what I can say now then is that dt, okay, so we have the 12, so dt like that equals 12, and instead of writing it in this form, I'm going to write it in the form r sine, as I've just done here. Okay, so 12 minus, or rather plus, because these terms are just swapped over, so 12 plus 5.772 and that's multiplied by the I don't need the bracket there just yet, let me take that out, times the sine of, now instead of putting theta, I'm going to write this fraction 360t over 365, so that replaces the theta from the original model. Okay, and I still have my minus 75.964, which is my alpha. Okay, so that is what I would have written down next, and then I need to calculate the minimum number of daylight hours in northern Scotland given by this model. Okay, now the minimum is when this part here is as small as it can possibly be. Okay, and when that occurs when the sign of this bracket is -1, and it's therefore going to leave us with 12 minus 5.772. So that is minimum value equals 12 minus 5.772, and that comes to 6.228. Okay, so that is the actual minimum value. And what that means is that the shortest day in that year has 6.228 hours of daylight. All right. Now for part D, we have to say when that minimum occurs. Okay. So we've worked out the minimum number of daylight hours is that, but when does it occur? Well, we need to find out what the value of t is when the sine of this bracket is worth -1. And the sine of an angle, if the sine of the angle is -1, that angle has to be 270 degrees. Because if you think about the sine graph, the first occurrence of -1 is when the angle is 270. Okay, so if I just very quickly illustrate what I'm trying to say there, if that's the sine graph, we know that the first maximum is at 1 when the angle's 90 degrees, so it's something like this. That's the maximum, then it comes down here, and the first minimum is at 270, and then we're back up there to 360. Okay, so this point down here is 270 degrees. Okay, so I just need to say that 360t over 365 minus 75.964, and that has to equal 270. Okay, and I've just got to solve that to find what t is. So a bit of rearranging. I get quite simply that I have 365 times, and it's going to be 270 plus 75.964. Okay, and if I divide all that by 360, that will give me t. Okay, so I've just rearranged this equation here. All right, and put that as equal to t. And that gives me, now let's see what that comes to. I'll have to put that on the calculator quickly because that's not done yet. So 365 minus times, so 270 plus 75.964, and all of that has to be divided by 360. And that comes to 350 point, which is equal to 350.769 days. So 350.769. Now I think in that case it's acceptable to leave that as 351 days. Okay, to 3SF. Okay, we've been working to 3dp for most of these things, and that is days. Okay, and what that means is that remember that is the number of days, t is the number of days into the year. So after the year started, on the 351st day, that's when the shortest number of daylight hours occurred, and at that time it was 6.288 hours. I'll put that in there as well, I think. Okay, so that's a modelling question using one of the addition formulae, processing it using r sine theta minus alpha, and then substituting these variables in to the model as appropriate to get these numbers. Okay, that's the question done.